We will proceed in parameterization of surface in calculus. Parameterization is not a new concept. Parameterization, knowingly, unknowingly, every calculus programmer who calculates integration, he does that. Like I have an ellipse x square by a square plus y square by b square equal to 1. This is the equation of an ellipse. Can someone calculate the area of the ellipse centered at the origin? X square plus a square plus x square by a square plus y square by b square equal to 1. Now, anyone would think that can I replace x with au and y with bv, au, bv, then it becomes u square plus v square equal to 1. This is method of substitution. This is method of substitution. This is also something like parameterization, where x is function of over u, x equal to a small u, y equal to b small v, then x equal to function over u, y equal to function over v, x equal to gu, g is a function, gu, y equal to hu, hv. Oh, I'm sorry. Okay, x equal to a, x equal to a u, and y equal to bv, right? So looks like there is a coordinate system called u and v similar to x and y, where x equal to au and y equal to bv, x square plus v is u square plus v square equal to 1. It turns up into a equation of a circle for which the area is pi r square, pi r is 1, pi. So simple, right? So if I am calculating the area for a, how I can calculate the area for a circle? One way is fx dx, fx equal to square root of a square minus x square, square root of a square minus x square. I believe we can proceed on it. So this is parameterization, where x equal to function over u and v and y equal to function over u and v. Method of substitution while calculating the integration, unknowingly we are doing parameterization. So this is typical example of parameterization. Okay, now we will proceed. So what we were calculating Jacobian. I mean, little bit I'll proceed in this importance of Jacobian. So consider that I am trying to calculate area of a circle, that is x square plus y square equal to 1. How I can calculate the area? In 3D, in 3D, I'm trying to calculate circle in 3D. In 3D, fxy dx dy, fxy dx dy is the kind of the way we calculate the volume. If I have xy plane and if I have a surface, then surface equation is fxy. Fxy integration over xy plane will give the volume under the surface. So volume of surface fxy dx dy. That is and then integration over the xy plane. So on xy plane I have circle where x and y are independent to each other. Y equal to square root of a square minus x square. It's not true. X square plus y square equal to a square. So that is a circle that someone draws on the xy plane. This is my xy plane. So on xy plane I draw a circle. Okay, in this circle, now this is the region in which I'll take x and y. Beyond that region, I won't take x and y at all. Understandable. Now with this circle, I map a surface. If this is a surface, if I calculate the integration of the surface along the xy plane, where an x and y is confined to a circular region, then it will give the volume of the surface under which the circle is there. Consider fxy equal to 1. So it's a flat 1. So we are trying to calculate volume, but since height is 1, unknowingly we will calculate the surface of the circle only. Because if I have a surface that is 10 by 20 and then height is 1, what is the volume? 1 into 10 into 20, that is 10 into 20. You are trying to calculate surface area 10 into 20. I am asking what is the volume. 1 into 10 into 20. 1 in multiplication has no significance. So 10 into 20. You are trying to calculate the area. If height is 1, then you are calculating the volume, but unknowingly you are calculating the area only. So fxy equal to 1, then dx dy integration over the x and y limit is around the circle. At the end, you are calculating the area of the circle, that is pi r square pi. If it is x square plus y square equal to 1. If it is a, then it is pi a square. Straightforward, right? Now, we tried the ellipse x square by a square plus y square by b square equal to 1. If that is the case, and x equal to au and y equal to bv, in that case, now it turns up into u square plus v square equal to 1. Now integration along the UV plane, and then height is fxy turns it into fuv, whatever it is 1 only, right? So 1 dx dy xy plane, how I can turn up into uv. This is where Jacobian comes into the picture. D of area, d small d and capital A. D of area. If we see integration, there are three parts. One is limit part, lower limit and higher limit. One is integrand, that is 1, and one is differential. So differential here is dA, dxy plane. If it is dxy plane is the differential, then that is equivalent to dx dy in Cartesian coordinate system. It is equivalent to du dv in uv Cartesian coordinate system. But if I transfer dxy to duv, it will not be straightforward, because equation is not straightforward. If x equal to u and y equal to v, then directly I can change dx dy to du dv. But x equal to au and y equal to bv. Now I believe everyone would say you can replace dx by a du and y by b dv. It will be ab du dv. But anyway, dxy dxy plane, if I change it to duv plane, Jacobian comes into the picture. D of xy equal to d of xy divided by d of uv into d of uv. D of uv is du dv. What about dxy by d of uv? This is Jacobian that needs to be inserted. So Jacobian concept is the most crucial concept in multivariable calculus, where you are trying to change in the area. Now I'll repeat it again before we proceed into further example. Now I have uv plane, I have xy plane. Now on uv plane there is a rectangle, and on xy plane I don't know. So there is a function which maps uv to x. There is a function which maps uv to y. So x in xy plane, x equal to g uv, y equal to h uv. G and u are function, g and bracket open, u comma v bracket close. Y equal to h bracket open, u comma v bracket close. So x equal to g uv, y equal to h uv. If that is the case, then it is something like this. On uv plane, I draw a rectangle. This rectangle would map to a 2D area, but it may not be a rectangle, depends upon the function. Now, if there is a unit change in rectangle, not a unit change in u and v, in rectangle, If rectangle is meter square, then there is 1 meter square of change, 1 unit change. 1 unit can be 1 meter square, 0.1, whatever 1 unit signifies. If there is 1 unit change in this rectangle, the mapped region, area region, how much meter square change we are seeing? dxy by duv. Change in UV area brings how much change in X. This explanation is not available anywhere else. Please do support us. So, if there is a unit change in UV area, how much unit change that we see in XY plane one region that is mapped from UV rectangle to some area in XY plane dxy small d bracket open x comma y bracket close by d small d bracket open u comma v bracket close dxy by d uv into du dv. This needs to be calculated. This is Jacobian. This no one understands this what it is. So if I talk about an area, calculation of an area, change in area with the change in xy plane, what it is. So I am reiterating. Okay, we have talked about it. So consider that I have a rectangle on xy plane. This is xy plane. If this is xy plane, this is x-axis. This is y-axis. This is z-axis. So z-axis I have a function, surface. This surface is fxy, function over x comma y. So this is x-axis, this is y-axis, this is xy plane. Now I can take xy, so many xy. For each xy I have z, fxy. If I connect for each sy, it resolves in a surface. Surface, if I have a rectangle on xy, this rectangle would map somewhere on the surface. So in this surface, it maps somewhere. This is a curved one, so it won't be a rectangle. It will be something else. Now, if there is a unit change in this rectangle on xy plane, how many unit change it brings? It brings on the surface area that it maps from the rectangle on this surface. So this surface is the surface is fxy dfxy by dxy dfxy by dxy, where fxy is function over x and y. Okay. Now to get the change in the area, per unit change area on the xy plane, we take any point on the surface as x, y, z. Then it is xi plus yj plus zk. This is the position vector of that point. Then d, if this is a position vector p, then dp by dx cross dp by dy. dp by dx, if I calculate dp by dx, if this is xy plane and there is any surface here, I take a point p somewhere here. If this is point p, then dp by dx is I plus dz by dx k. dp by dy is j plus dz by dy k. dp by dx has vector I plus dz by dx j. It has I component, j component. Means dp by d, if this is x-axis, this is y-axis, this is z-axis, then dp by dx would vary in xz plane. dp by dy would vary in yz plane. At any moment, if dp by dx is like this, at any moment dp by dy is like this, it gives me this surface. If dp by dy is like this, oops, dp by dx, dp by dy and dx, it gives me surface like this, bent. So area vector is along this direction. If it is this, then area vector is along this direction. If it is like this, then area vector is along this direction. Okay. It may not be that always the angle would be 90 degree between it. Not true. It is like this. And then this is like this. See the angle between it. Okay. It is like this. This is varying in xy plane. This is varying in yz plane, xz plane. Now see the angle, not required. So if I do cross product of this with this vector and this vector, it will give me the area. That is the surface area. Now dp by dx, the change in p with respect to change along the x-axis cross dp by dy would give exactly the change dp by dxy plane. How much p vector is changing if there is a unit vector change in xy plane. That is giving the area of the surface, that area of the surface that is changing as per the unit change along xy plane, dp by dx cross dp by dy. But this is change in the area. So whatever we receive cross product of the vector, it is in vector form. This is change in area vector. If I want area vector dp by dx cross dp by dy, then I have to integrate with the xy plane back. So if that case, I get the actual area vector. Otherwise, dp by dx cross dp by dy gives me rate of change of area vector. So if someone understands this concept, then he is understanding the multivariable calculus. Now we are trying to calculate the, if it is independent component is xy plane and dependent component is the surface, then change in the surface area when there is a unit change in the xy plane rectangle. What about if I have uv plane and I have xy plane? If x equal to function over uv, that is guv, y equal to function over uv, that is huv, then xy is dependent component and uv is independent component. So it is something like xy plane. Now I can replace with the uv plane, and the surface what we were talking z equal to fxy. Now surface is xy plane, uv plane, xy plane. Xy plane is dependent upon uv plane, where x is function over u and v, y is function over u and v. dxy by duv. How much this xy plane would change if I draw a rectangle on uv plane and make a unit change over it? dxy by duv. If that is the case, then if I consider xy as a vector, then dp by du cross dp by dv is gives me rate of change of area in xy plane with respect to unit change in uv plane. dp by du, where p equal to xi plus yj, dp by du, dx by dui plus dy by duj, dp by dv, dx by dv plus dy by dvj. If I do cross product of these two, what I get? dx by du into dy by dv k minus dx by dv into dy by du k. So net rate of change of area, this is what we want. dxy, actually the integration what we were in way to calculate the area of a ellipse, not ellipsoid, ellipse. Area of a ellipse is integration over the ellipse, that is u square plus v square equal to 1, where actual was x square plus a square, x square by a square plus y square by b square equal to 1. That is the ellipse equation. X equal to au and y equal to bv, u square plus v square equal to 1, where integration is along the uv plane. Earlier it was integration along the xy plane, now it is uv plane. Now fxy 1, here also 1, and then now the kind of 1, it is 1, so 1 constant remain 1. Now dx dy, so dx dy plane now change into dxy by duv into duv. So duv is du dv, dxy by duv, what it is? This is called Jacobian. So xy, if I consider a position vector xi plus yj, then differentiation with the uv rectangular area is nothing but dx by dui plus dy by duj cross product with dx by dvi plus dy by dvj, and it would settle down as dx by du into dy by dv minus dx by dv into dy by du. K vector, if I take magnitude, k vector will go away. And then du dv. What is dx by du? So dx by du here is a. What is dy by dv? That is b. A into b. Dx by du. Now dx by dv 0. Dy by du 0. Now it is a into b. A into b du dv integration over the circular region. So that is u square plus b square equal to 1. Integration over a circular region is pi r square. Pi AB is the surface area of an ellipse. X square by a square plus y square by b square equal to 1. It's a famous example. So if someone knows how to calculate the volume, how to calculate the what we have seen till now, if you see it clearly, what we have seen till now, whatever we have seen till now is nothing but the derivation of a function over x-axis, derivation of a function over any axis, that is called directional derivative along a vector u. That is famous for as this name. Integration of a function along x-axis. Okay, integration of a vector along any vector. It is also called line integral. Integration of a function, integration of a vector along a surface xy plane, that is normal dx dy. Integration of a surface along any plane, that is called surface integral, that is used in flux calculation, whereas line integral is used in curl calculation. But we have never seen in differentiation of a plane with another plane. Differentiation of a function along an axis or along a vector, we have seen directional. But differentiation of a function or differentiation of an area vector along another plane, this is the most complex one in multivariable calculus, also called Jacobian. Okay, it is really a jack. So it is really king, derivative of an area in one plane with respect to area in another plane. Area, not line. So this is something that is diamond. If someone crack it, then he cracked the multivariable calculus as far as I understand. Okay, now if that is true, is there any other proof? What proof is given? Whatever is given, it is through us. Please support us. +91 is India country code, and then 94831 60610. +91 and then 94831 60610 is the telephone number. So please do support us. Anyway, what are the proof available in the books, internet, or in loose term, what are the proof available in the market? So how someone has proved that dxy by duv, what it would be if it is dy by dx by du into dy by dv minus dx by dv into dy by du. If this is the resultant, how someone can prove it? This is highly useful in machine learning. So machine learning and artificial intelligence is the consumer, is the customer of multivariable calculus. Otherwise, multivariable calculus was not famous at all. Who will go and calculate derivative along a surface that is in different coordinate system? Dfxy by dxy plane also understandable. Dxy by duv. So this is usable in artificial intelligence, this kind of thing. Okay, someone can proceed on it. I am not stopping it. dxyz by duvw. So differentiation with respect to volume, but it will be in a kind of series of this concept only. So first was a matrix multiplication. If the cross product is there, then matrix multiplication is involved. Then go beyond the two layer of matrix multiplication. Then it will come as for the volume also, that we will see. Now what is proof that is available? The proof that is available in market is, now consider that I have UV plane and I have XY plane. Now UV plane I have a rectangle, and on XY plane I don't know whatever it is. How it is mapped depends upon the mapping function. If that is the case, then there is a 2D some surface is there. Now in the surface, consider in the rectangle here, there is a corner. If there is a rectangle, then there is a left bottom corner. That point is called u comma v, and the length of the width of the rectangle is u plus delta u. Height of the rectangle is v plus delta v, where the u and v is the point at the left bottom corner of the rectangle. Now it mapped to some shape here. It is not rectangle. Where the point u comma v maps to point x comma y. Okay. Now if I take two vector here, one vector goes this side of the shape and one vector go other side of the shape. It is not rectangle. If I say this side of the shape, since it is delta, so we can consider as a straight line. This is what I don't like, but this is how it is. So now consider on the, if this is x comma y or GUV comma HUV, then if I take this side, then I call it a vector, and if I take other side, I call it v vector. Vector is nothing but difference of 2 points. If I have a point x0 y0, another point is x1 y1, then vector connecting these 2 points is x1 minus x0 I plus y1 minus y0 j. If that is true, then a vector is, if this point is x comma y, other point is x1 y1, then this vector is x1 x0 minus x0 I plus y1 minus y0 j. So that is the a vector. Now x0 y0 is g u comma v, whereas x1 y1 is g u plus delta v, g u plus delta u comma v. Similarly, b vector, so this a vector is g u plus delta u comma v minus g u comma v. Now b vector is g u plus v plus delta v minus g u v. Now these two vector, a vector is g u plus delta u comma v minus g u comma v I x component plus h u plus delta u comma v minus h u plus delta u comma v j. This is the a vector. Now b vector x component, that is g u plus u comma v plus delta v minus g u v I plus h u comma v plus delta v minus h u comma v. I would repeat, the v vector is g u plus u comma v plus delta v I g u comma v plus delta v minus g u v I plus h u comma v plus delta v minus h u comma v j. Now these two, if I do cross product, I get the area vector. Now the first term, that is a vector and b vector. The A vector in xy plane, 2 points mapped along x side for the rectangle in UV plane. So this A vector and B vector. So A vector, I can represent it as A vector is G U plus delta U comma V minus G U V divided by delta U into delta U. Makes sense? I plus H U plus delta U comma V minus H U comma V divided by delta U into delta U J. So first term would become dg by du into delta U I plus dh by du into delta U J. Similarly, B will become dg by dv delta V I plus dh by dv into delta V J. If I do the cross product, then it becomes dg by du into dh by dv minus dg by dv into dh by du k vector, and delta u delta v will go outside. So now the area vector which was dx delta x and delta y, now it changed into dg by du. G is x equal to guv. So dx by du into dy by dv minus dx by dv into dy by du. You take the absolute value and delta u means du dv. I had taken a small region map. If you add all the region, so if there is a rectangle here, big rectangle, full region is there. I had taken a small delta u delta v rectangle. For that, if this is the equation dx by du into dy by dv minus dx by dv into dy by du, take the absolute value delta u delta v. If I add for all the rectangle, delta u and delta v will become du dv. Okay, so the net Jacobian, so dx dy transformed into du dv, where the extra thing that is attached now, that is called Jacobian determinant, that is nothing but dx by du into dy by dv minus dx by dv into dy by du. That is differentiation of a mapped rectangle in one plane divided by differentiation of the independent rectangle in another plane, Jacobian. We will do one more proof. Okay, I don't have that much stamina. Okay, so we will do one more proof, that is through the parametric vector. So this was simply through an kind of a vector where infinitesimal small rectangle delta u and delta v rectangle I took and mapped into xy plane, and that we saw it is dx by du into dy by dv minus dx by dv into dy by du, and then delta u delta v. If I go for addition all this rectangle, because at the end Riemann approximation is called, take a small region and get the value and add for all the region. This is the basic integration. Take a small region and then add for all the small region. The full region, if you keep adding, then it becomes dx by du into dy by dv minus dx by dv into dy by du, and delta u ij delta Vij, where Ij is the ith component along, if there is a full surface and I distribute into n part along x-axis and n part along y-axis, along u-axis and v-axis, each sub-rectangle will be represented as I comma j. So delta Uij, delta Vij. Now if I add for all the rectangles, then it will become pure integral. Then it is du dv. Okay, so that is the scenario. Now we will take another parametric vector proof. We'll do in another session. and we will do more example. I will try to calculate the area of ellipse through typical area way, through vector way, so many way, and we will have tons of examples. So this session will proceed with example, so that it will hit the practicality would hit the brain. So that is the concept we will proceed through.